Hello everyone, welcome back to the channel. This question was asked in IIT JEE 2025 Advanced and it's a pretty good question. It carried 4 marks and the question is extremely simple, and if you get your concepts right, you could answer this question in less than 2 minutes and get 4 marks, which is really huge. So let's get into the problem, and I will also give you the concept associated with dipole and such questions and how to answer this question without actually going and solving in an exact manner. Okay, but let me first read out the question. List 1 shows 4 configurations, each consisting of pair of ideal electric dipole. Okay, so what is dipole? Dipole is a pair of charge. Okay, one positive, one negative, and it is separated by distance 2a, and the dipole moment is written as q and the distance between them, so which is 2qa, and the direction of dipole moment is from negative to positive. So from negative to positive is dipole moment direction. Okay, fine. Now let's continue reading. Each dipole has a dipole moment P. So P, as I said, is nothing but 2qa, oriented as marked by arrows in the figure. So as I said, dipole moment acts from negative to positive. So if you see the arrow, which means that there is a negative here and then there is a positive here. And this is another dipole. So negative and plus positive. Okay, and like that for all other options. In all configurations, the dipoles are fixed such that they are at a distance 2r apart along the x direction. So if you see, they have given the axis also. This is x-axis and this is y-axis, right? I and j. The midpoint of the line joining the two dipoles is x. So everywhere you see there is a point which is midpoint. The possible resultant electric fields E vector at x are given in list 2. So here you have multiple configurations of two dipoles, and here you have the resultant electric fields, and we need to match the right pair. Okay, that's the job. But before we go ahead and solve this problem in a relatively easy manner, let's see some of the associated formulas here. Okay, so the first thing we want to compute is what is the electric field. Let's say if I take one line which is perpendicular bisector to the dipole moment, and let's say it's at point A, which is at distance x, I want to compute the resultant electric field. Okay, so if you analyze this, the electric field, because of this positive charge, is going to be in this direction, let's say E, and electric field due to this negative charge is going to be in this direction. And if you take the vector sum, since the charges are exactly same, so the resultant would be in this direction, right? In negative j. If let's say we take this as I and this as j, and the component of let's say this component, this component, let's say if this is theta, this is theta and theta, so this will be E cos theta in this direction, and this will be E cos theta in this direction. So what is the electric field in I direction? So EI, if you take, will be E cos theta I plus E cos theta minus I, because this is acting in minus I direction, hence it is 0. And how much is in j direction? So E sine theta j minus and minus E sine theta j, right? If you take the component in this direction, j direction, and therefore this is minus 2E sine theta j. And what is E? So E is nothing but 1 by 4 pi epsilon naught and Q by R square. This is R, let's say. Okay, so the EJ will be minus 2 4 pi epsilon naught q by r square. And what is sine theta? So sine theta is nothing but a by r. So we can then write EJ as minus 2qa 4 pi epsilon naught r cube. So if you see, this is nothing but dipole moment. So minus p by 4 pi epsilon naught r cube. So this is the expression for this resultant electric field at point A, which is at a distance, let's say x, which is a perpendicular bisector of the dipole moment. Okay. Now, if you consider the another option, which is, let's say this is plus q and this is minus q, and now let's say this is midpoint, and I want to compute E at this point, let's say this is B, then you will see that because of plus q, there is an electric field in this direction, and because of minus q, there is an electric field in this direction, right? This time they are not equal. Why they are not equal? Because the distance from the charges are different, okay? But they are going to be in I direction, right? If this is I. So we can write the total electric field E will be E1 plus E2, and E1 is Q by 4 pi epsilon naught 1 by, let's say, r square if this distance is r. Now this is A, plus minus q by 4 pi epsilon naught 1 by r plus 2a square, right? Therefore, q by 4 pi epsilon naught, if I take 1 by r square common, then 1 minus, I can write this 1 plus 2a by r square. This can be also written as 4 pi epsilon naught r square 1 minus 1 plus 2a by r minus 2. Now we know that a is very, very less than r, because typically in any dipole the a is very small, which means that for any 1 plus x to the power n, if x is less than 1, then this becomes 1 minus nx, right? So here also we can simply write it as q by 4 pi epsilon naught r square 1 minus 1 minus 4a by r, and minus minus will become positive here, and this will cancel out, and therefore this becomes 2 into 2qa by 4 pi epsilon naught r square into r, and therefore this is 2p by 4 pi epsilon naught r cube, which is nothing but p by 2 pi epsilon naught r cube. Now if you consider this one is half of this. So we get the actual electric field at a distance r on the same axis as dipole, 2 times the actual electric field when we take it at the perpendicular bisector direction, okay? So you don't need to derive this for this problem, but I just wanted to show you how to compute the electric field for a dipole, which is no different from any other usual scenario, okay? Now given this, let's try to answer the question, okay? So the first option, both the dipole moment is in the positive z direction, okay? And we want to compute the electric field at x. So this is the first dipole and this is another one, right? And we know that because of this, the electric field will be in this direction, and because of this also it will be in this direction. But both will just add up to the electric field at x point, right? We just computed it here. It's in negative j direction. So the E will be P 4 pi epsilon naught r cube and this is in negative j direction. That's why negative sign. 2 because both are adding here, right? And anyway, if you just draw the line here, this is the electric force because of this charge, and this is for because of this charge. Because of this, it is just going in this direction. Because of this, it is also getting added here. So if you take the vector sum here, okay, so for this one, P, this looks like the right answer. So P definitely is 2. So we can write P matches with 2. Okay. Now let's figure out the second option. What is the second option? So one dipole moment is positive j, another one is negative j. So again, just draw the picture. Okay. And at x, because of this in this direction, because of this in this direction here, and because of this it is negative, so it will be in this direction, and this is positive, so it will be in this direction. Now if you see, all are cancelling each other, like this vector is getting cancelled with this and this with this, so total electric field we can simply write as 0. And this is the option. Let's say for Q it is 1, right? So we can write for Q it is 1. Okay. Now let's see the third arrangement. The third one is one dipole is in positive j, another one is in positive I. Okay, so let's do that. So we just draw this dipole and another dipole here, and this is somewhere here we want to compute. So just draw the vector diagram here. So because of this charge, it is in this direction. Because of this in this direction, so there is a resultant in this direction, which we know is going to be E1, let's say, is minus P by 4 pi epsilon naught RQ J. And because of this, if you see, the electric field is, because of this is in this direction, and because of this in this direction. Okay, so the resultant will be in I direction. Okay, and how much is this? This is, we know that we have just computed, this one is 2 times the other one, right? If you see, so this one E2 is P by 2 pi epsilon naught RQ in I. So the resultant electric field will be E1 plus E2, which is P by 4 pi epsilon naught RQ. If I take this, then 2I minus J, right? So let's try to find out if this is there in the option. So here it is, 2I minus J, right? So for R, it is going to be 4. So R is 4. Okay, and the last arrangement is both are in I direction. Okay, so this one is in I direction, this one is in I direction. Okay, and somewhere here is the X point. So if you see, we are just computing at X everywhere. Okay, so because of this, we know that it is going to be in this direction, and this one will further add in this direction, right? So the total E will be 2 times P by 2 pi epsilon naught RQ I, and that is nothing but P by pi epsilon naught RQ I. Now let's see if this is there also in the option. So it's there. So S is 5. So S is 5. Okay. So 2145. Now let's see. This is not, no, 215. So C. So the answer is C. C is the answer. I hope you learned few things here and solve such problems. You don't actually need to deduce the formula. You can just use the vector addition to come up with the answer. So I hope you enjoyed this video and you liked this video. Please do subscribe to the channel and share this video with your friends. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.